In-class activity 11F, 2 sample tests for proportions. In 2004, 2 University of Chicago economists, Marianne Bertrand and Sandhill Muller-Nathan, decided to conduct an experiment to test for labor market discrimination. The investigators created 4,890 mock identical resumes, which were sent to job placement ads in Chicago and Boston. To gauge market racial discrimination, each resume was randomly assigned either a commonly white or commonly black name. The experimenters then measured the proportion of resumes from each group, white and black, that received a callback. 1, conducting this experiment took a lot of work and resources. Why didn't the investigators just compare observed black and white wages in current data? Why do you believe they went through all the trouble of conducting this experiment? Now, answers will vary, but the essential reasons are provided in this possible answer. This is a sample answer. If they only use observed wage data, there may be confounding factors that would make the effect of labor market discrimination hard to identify. For example, differences in wages may stem from inequity in education, differences in social networks, and differences in career choices, rather than through labor market discrimination. Instead, investigators chose to conduct an experiment that controls for confounding factors by using identical resumes and random assignment to different names. This allows them to identify the causal effect from discrimination. Okay, the objectives of this activity. You will understand that 2 sample inference situations involve samples from 2 populations. The null hypothesis in 2 sample tests equates the 2 population parameters. The test is conducted under this assumption. The results of a 2 sample test provide evidence for concluding if the 2 population parameters are statistically different. You will be able to conduct a 2 sample z-test for proportion and interpret the result in context. So questions 2 to 6. These questions reference the study results, which are summarized in the table below. So we have those called back, those not called back, and the total. Commonly white names, commonly black names, and the total here. We have 246 for the white, 164 for the black. Not called back is 2199 for the white, 2281 for the black, and the totals are the same, 2,445, 2,445. We define P1 through proportion of the commonly white named resumes that received callback, and P2, the true proportion of commonly black named resumes that received callback. So P1 is for the white, P2 is for the black. Now, before conducting a test, let's explore the results. Part A, let's calculate the sample proportion P1 and the sample proportion P2. The sample proportion of the white and black named resumes that received callback respectively. How do we get the sample proportion? We take the number that called back divided by the total number, 2445. And this is it. So for the white is 246 divided by 2445. That is 0.101. And then for the black, we have P2 hat, which is 164 over 2445. This reduces to 0.067. So part B, are these two sample proportions different enough to show that the difference didn't occur by chance alone? Justify using basic reasoning without conducting a hypothesis test. We know that the answers will vary, but here is a possible answer. This difference is unlikely to occur by chance alone, even though the difference between these proportions, 10.1% and 6.7%, seem small at first. The sample sizes are very high, 2,445 per group. It is hard to imagine that one group would have so many more employers that rent candidates lower by chance alone. So let's look at part C. If the sample sizes were only 20 resumes per group, would you be more likely to believe the difference in proportions could have occurred by chance alone? Explain. Of course, if the sample size is small, the possible answer is yes. At such low sample sizes, it is more possible to believe that one group may have had resumes sent to a set of tougher or easier employers by chance alone. Therefore, these chance differences might yield the differences we see. That is part C. So let's look at number 3. If we wanted to test if the difference in callback rates is statistically significant, should we use a one sample or two sample inference procedure? Explain. So if we want to know if the difference in callback is statistically significant, should we use a one sample or two sample inference procedure? You can pause the video, think about it for a moment. Okay. We should use a two sample procedure. We are testing for a difference in proportion using samples from two populations. So we definitely should use two sample procedure, not one. Number 4, we will now conduct a two sample z-test for proportion. Here are the hypotheses for the test. So null hypothesis is P1 minus P2 equals 0. The alternative hypothesis is P1 minus P2 is not equal to 0. The first one says they are the same, so the difference is 0. The second one says they are not the same, so the difference is not 0. So in which hypothesis are the callback rates between the groups equal? In which hypothesis could the commonly white names get higher callback rates? The null hypothesis assumes the rates are equal. The alternative hypothesis proposes that the callback rates differ, including that white names may receive a higher callback rate. B, what is the null hypothesis value of the difference in proportion? The null hypothesis assumes that the proportions for both groups are same, so that the difference equals 0 in the null. So the difference equals 0 in the null. That's why we had P1 minus P2 equals 0. Let's look at number 5. To ensure our inferences are accurate, we must check certain conditions for conducting the two samples Z test for proportion. Part A, confirm that the data was collected via a random sample or an experiment with random assignment to treatment. This allows us to propose that we have comparable experimental groups. Again, we confirm that the data was collected via a random sample or an experiment with random assignment to treatment. This allows us to propose that we have comparable experimental groups. The answer is yes. Our experiment had random assignment of employers to treatment. The treatment here being the name types, black versus white. They were randomly assigned. Okay. Part B. Confirm that we have a large enough sample size to meet the sample size condition. This will help ensure that the underlying sampling distribution we use to calculate the p-value can be modeled with normal curve. The conditions are listed below. N1 times PC is greater or equals to 10. N2 multiplied by that is greater or equals to 10. Here, PC is the combined sample proportion from both groups. N1 and N2 are the sample sizes from group 1 and group 2, respectively, the white and the black groups. To calculate the combined or pooled sample proportion, add the total number of candidates that received callback in both groups and divide this sum by the total number of people in the study. So PC equals X1 plus X2 divided by N1 plus N2, where X1 and X2 are the number of successes from group 1 and 2, the ones that received callback. And we confirm that these conditions are satisfied. we can see that PC, which is 410 divided by this, we added the two total sizes, is 0.081. When we multiply by the sample size N1, remember N1 and N2 are the same, we get a number bigger than 10. We get 205.4, which is definitely bigger than 10. And when we multiply by 1 minus PC, we get thousands, so it's definitely bigger than 10. So in both conditions, everything is satisfied. The 4 conditions we had before are verified. These conditions, they are all verified here. So we say, yes, the conditions are satisfied. So note, the final condition is that the sample sizes are each less than 1/10 of the size of the populations from which they were drawn. N1 being less than this, 0.10 times N1, and N2 is less than 0.10 times N2. This helps ensure our estimates for the standard errors are accurate. However, this condition does not need to be checked in the case of a randomized experiment. Conditions for 2 sample z-tests for proportions. The first condition, large counts. Check that N1 PC is greater or equal to 10, N2 PC is greater or equal to 10. And when we multiply by 1 minus PC, we still get numbers greater than 10. The second condition is to check random samples or assignment. Check that the 2 samples are independent and random samples, or that they came from randomly assigned groups in an experiment. Let's say that again. Random samples / assignment. Check that the 2 samples are independent and random samples, or that they come from randomly assigned groups in an experiment. Number 3, 10%. Check that N1 is less than 0.10 of N1 and N2 is less than 0.10 of capital N2. Okay. Number 6, we can use compare 2 population proportions from the app, https://dcmathpathways.shinyapps.io/2sample.prop. Select the number of successes option and input the relevant data from the study. Under types of inference, select significance test and appropriate alternative hypothesis. Part A, interpret the observed difference. How was this calculated and what does it mean? We're going to show this in a moment. But let's look at part A. The observed difference is 0.0335. The app gives it, but we can get it by subtraction. It's the difference in sample callback rate between the commonly white and commonly black name resume groups. P1 hat minus P2 hat is 0.101 minus 0.067. This will give us 0.0335, which rounds to 0.034. So if you round this number, we'll get this. And we'll get it by subtracting the proportion we got before. So this is the app we're talking about. So we go to this website, enter the values. We have highlighted the figures we entered, the numbers for the white, the black, the total number needed. After filling those figures, it's light here. But it will display all the figures. Once these numbers are entered correctly, it should display correctly and show all the ones that are needed. It's very light here, but it should be easy once you're looking at it on a computer. So that test will show for part B to state and interpret the z-test statistics. It shows it on the table from the app that the z-test statistic is 4.23. What does this mean? This means that our observed sample difference is 4.23 standard errors above the null hypothesis value 0. So a z-statistics of 4.23 means that our observed sample difference is 4.23 standard errors above the null hypothesis value, which is 0 in this case. So C, we want to state and interpret the p-value. Again, from the app, we see that the p-value is 0. It's boldly displayed as 0. This means that the probability of obtaining a sample difference this large or larger by chance alone, if the null hypothesis is true, is very small. It's less than 0.001. D, using the information above, draw a conclusion for this test. State what your conclusion means in the context of the study. Use significance level alpha equals 0.05. So what does this mean? Because our p-value is very low, we have convincing evidence to reject the null hypothesis. We have convincing evidence that the callback rates differ between groups. Specifically, it appears that the commonly white name receive a higher callback rate than the commonly black names. Finally, we found a difference between callback rates as statistically significant, but is it practically important? Justify your answer using the observed difference in sample proportion. Again, this is number 7. We found the difference between callback rates was statistically significant, but is it practically important? Justify your answer using the observed difference in sample proportions. Answers will vary in terms of the words used to state it, but the essential point will be the same. And this is it. This is a possible sample answer. Although a difference of 3.4 percentage point, which is 10.1% minus 6.7% is 3.4%, doesn't seem like a lot. It is practically important. Note that the overall callback rate was low, 8.4%. So even a small difference in callback rate can be meaningful. To see this, we can calculate the relative difference in the likelihood of getting a callback. So this subtraction divided by 6.7%, that will give us 50.7%. So commonly white names were 50% or more likely to get callbacks. That is practically important. That's it. We'll see you at the next one.